Okay, guys, welcome. Today we're going to talk about forms that will lead to quadratic equations, right? So now there's certain equations that at first glance don't look like they're a quadratic equation, but either through some kind of transformation or in the process of solving them, you're going to end up with a quadratic equation. And then, of course, you can solve them by the methods that we've previously talked about. All right, now the first one we're going to talk about is what's called a radical equation. And all that means is, let me write this out so it's a little bit more clear, an equation where you have a radical within it, right? Now, one thing that you need to do is at the end, sort of like when we were solving rational equations, you need to check that all of your answers at the end still result in a true statement, right? So, and if you have any that don't, you would throw them out, and those are your extraneous solutions. Okay, so the idea for solving a radical equation is to first get the radical, or if there you have more than one radical, get one of them by itself on one side of the equation, right? And then, of course, what you're going to do is you're going to raise each side to a power that's going to remove that radical, right? And then if you have more than one radical term, you're just going to keep doing that until you have no radicals left, and then you just solve whatever's left. All right, so let's do an example. So in part A, we have x minus square root of x minus 2 is equal to 4. Right? So if I want to get the radical by itself, I could add square root of x minus 2 and subtract 4 from both sides, and that would give me that x minus 4 is equal to radical x minus 2. Well, now we can square both sides. Right? If we square both sides, then on the left, I'm going to get an x squared minus an 8x plus 16, right? That's a perfect square, so we can just use that formula. And then square root of x minus 2 squared will just give me an x minus 2. Well, now we have a quadratic equation, so let's move the x and the 2 over. So then we get x squared minus 9x plus 18 is equal to 0. So now, of course, what are two numbers that multiply to 18 and add to negative 9? That's x minus 6, x minus 3. All right, so of course this gives you x equals 6 and x equals 3. All right, but now we need to check both of these. All right, if we check 6, in the original equation, we're going to have a 6 minus square root of 6 minus 2 is equal to 4. Well, this is 6 minus square root of 4, which is 4, and 6 minus 2 equals 4, and of course that's true, so that's good. All right, if we check 3, we're going to have a 3 minus square root of 3 minus 2 is equal to 4, and we get a 3 minus square root of 1 is equal to 4, so we get a 2 equals 4. So that's not true, so then we need to throw out 3. All right, so your only solution here is 6. Okay, let's look at part B. Part B, we have x minus square root of 1 minus x is equal to negative 5. Okay, well, let's add this square root term over and add this 5 over. So I'm going to get that x plus 5 is equal to a square root of 1 minus x, right? Once I add it to this side. So now we can square both sides. On the left, I'm going to get an x squared plus 10x plus 25 is equal to 1 minus x. So now let's subtract 1 and add x to both sides. We'll get an x squared plus 11x plus 24 is equal to 0. So now, of course, we can think of this as x plus 8 and an x plus 3 is equal to 0. So we get x equals negative 8 and x equals negative 3. So now we need to check, right? If we check negative 8, let's see, we're going to get a negative 8 minus a square root of 1 minus negative 8 equals -5. And this will give me a -8 minus square root of 9, right, which is a -8 minus 3. So we get -11, right? So that one's not good. So we got to throw out -8. If we check -3, right, we're going to get a -3 minus the square root of 1 minus -3. Does that equal -5? Well, that will give us a -3 minus a negative will become a plus. So square root of 4 equals -5. And this will give me a -3 minus 2, which is -5. So -3 is good. All right, so it's very important to check your solutions here. Okay, now what happens if you have more than one square root? Well, then it gets a little bit more interesting. Right, so in part A, for example, we have square root of 2x minus 4 minus square root of 3x plus 4 equals -2. Well, let's get the first one by itself. So let's add 3x plus 4 to both sides. And we get a square root of 2x minus 4 is equal to a square root of 3x plus 4 minus 2. And now we need to square both sides. Well, on the left side, I just get 2x minus 4, which is fine. But now on the right side, I need to FOIL this. So I'm going to think of this as multiplying by itself twice, just to sort of spell this out. Now, if we FOIL, the two square root terms are the first terms, and that's just going to give me a 3x plus 4. Now, if I multiply -2 by this square root, I'm going to get -2 square root of 3x plus 4. And then I'm going to get it again. I'm going to get a -2 square root of 3x plus 4. And then -2 times -2 is plus 4. So let's combine our like terms. So on the left, I still have 2x minus 4 equals 3x. And then this plus 4 and plus 4 will give me a plus 8. And these two square root terms are going to give me a -4 square root of 3x plus 4. Right, so now I just have to get this square root by itself. So I'm going to add this to both sides. Plus 4. And we're going to subtract 2x and add 4 to both sides. So once we get all this cancellation happening, we're going to get that 4 square root of 3x plus 4 is equal to x plus 12. Okay. So now you can either divide by 4 or you don't even have to. Let's just leave the 4 on this side so that this FOIL is a little easier. And we're going to get 16 times 3x plus 4 is equal to an x squared plus 24x plus 144. So this will give me a 48x plus 64 equals x squared plus 24x plus 144. And if I move this stuff over, I'm going to get 0 is equal to x squared, and then we'll get a minus 24x. Let's see, 144 minus a 64 should give me an 80. All right, so now we need two numbers that if we multiply them together will give me a positive 80, and if I add them, I get a negative 24. So that should be x minus 20 and x minus 4. So we get x is equal to 20 and x is equal to 4. All right, and then of course we have to check these. So if we check 20, we're going to get a square root of 2 times 20, so a 40 minus 4 is a 36, minus square root of 3 times 20, which is 60 plus 4, so a 64. Does that equal -2? Well, this gives me a 6 minus 8, which is -2. So that one's good. And then if we check 4, I believe was the other one. Yeah. So if we check 4, we're going to get a 2 times 4, which is 8 minus 4, so square root of 4, minus a square root of 3 times 4 plus 4, so 16. Does that equal negative 2? So we get a 2 minus 4, which is also negative 2. So they're both good this time. Okay, now in part B, we have a square root of 5x minus 1 minus the square root of x plus 2, and that equals positive 1. All right, so let's add one of them over again. And we get that square root of 5x minus 1 is equal to square root of x plus 2 plus 1. So let's square both sides. And we'll get a 5x minus 1 is equal to, and again, when we FOIL this out, eventually you can get x plus 2 square root of x plus 2 plus 1. All right, so let's move everything over. So if I subtract this x, and then the 2 and the 1 will give me a 3, so let's subtract 3 from both sides. So we're going to get a 4x minus 4 is equal to 2 times square root of x plus 2. And this time I'll divide by 2 since that left side will divide nicely. And then I'll get a 2x minus 2 is equal to square root of x plus 2. So now when we square, we get a 4x squared, and let's see, I believe minus an 8x, right? If I do 2x times minus 2, that's a negative 4x times 2, negative 8x, plus 4 is equal to x plus 2. So if we move this over, we get a 4x squared minus 9x plus 2 is equal to 0. So then if we do 4 times 2, we get 8. And we can use negative 1 and negative 8 to both multiply to 8 and add to negative 9. So we're going to get a 4x squared minus 8x minus 1x, or just minus x, plus 2 is equal to 0. So if we factor by grouping, we're going to get a 4x taken out of here, so an x minus 2. Factor in negative 1 so we can get x minus 2 here. So we get x minus 2 times a 4x minus 1. So we get x is equal to 2, and x, once we do add 1 and divide by 4, x is 1/4. So now we have to check. Okay, so now if we check 2, right, so the original equation was square root of 5x minus 1 minus square root of x plus 2. Does that equal 1? So if we plug in a 2, we're going to get a square root of 9 minus square root of 4. Does that equal 1? And of course it does, because it's 3 minus 2. So that's good. If we do 1/4, we're going to get a square root of 5/4 minus 1 minus 1/4 plus 2 equals 1. And this first one will be a square root of 1/4, which is 1/2. And this next one will be a square root of 9/4, which will be a 3/2. And this gives me negative 1, so I need to throw out 1/4. All right, so those are some radical equations. Now, radical equations aren't the only equation that will sort of lead you to a quadratic, right? So, for example, if you have something like x to the 4th minus x squared minus 2 is equal to 0, that's something that looks like a quadratic, but is sort of off a little bit, right? Instead of this being a square, you have this as a 4th power, and instead of this being a 1st power, you have that as a 1st power. So what we do is we just think about, well, what if x squared was like x, right? And we're actually just going to call it another letter. We're just going to usually call it 2. Well, if x squared is like u, then x to the 4th is like u squared. So we can think of this as u squared minus u minus 2 is equal to 0. And now it's a quadratic, right? So now you could solve this, right? So that's what we're going to do here. We're going to do a couple of examples of that. So first, in this example, I just want to talk about, well, what's the appropriate substitution that you could make? Right, so you have 2x squared plus 7x to the 3rd minus 4 is equal to 0. Right, now the way that you can always check is just look at whatever the middle term is. Right, that's your only candidate, right? So here you have an x to the 6th, you have an x to the 3rd, and you have a constant, right? So you always need a constant, and then you always need sort of the 2 higher variable terms, right? Your only chance is that if u can be x to the 3rd, right? Well, what's u squared? U squared is x to the 3rd squared, which is x to the 6th. And that's what we have over here. So since that happens, u is equal to x to the 3rd is the substitution that we could make. Right? And then similarly in part B, you have y to the 2/3 minus 3y to the 1/3 minus 10 is equal to 0. So again, we try the middle term. So if we let u equal y to the 1/3, would that work? Well, we would get for u squared, y to the 1/3 squared, which is y to the 2/3, right? Which is what I have over here. So that would work. All right, so that's sort of the idea behind making the substitution. All right, so now we're going to actually solve them. All right, so now we're going to indicate the substitution that would work and then actually solve it. So in part A, we have 2 over z squared minus 4 over z plus 1 is equal to 0. Now, if we let our u equal 1 over z, right, we don't want 4 over z because 4 is like our constant, then what's u squared? Well, u squared is 1 over z squared, which is 1 over z squared, right, which is what we have over here. So now if we make this substitution, we're going to get the 2 still, but 1 over z squared I'm going to replace with u squared. I'm still going to have the 4, but I'm going to replace 1 over z with u. And then plus 1 is equal to 0. Right? Okay, so now if I do, let's see, 2 times 1, I'm going to get a 2, but I'm not going to be able to multiply to 2 and get 4. So let's use the quadratic formula. We get u is equal to a negative b, so a negative negative 4 is positive 4, plus or minus b squared, so 16 minus 4 times 2 times 1 over 2 times 2. So we get a 4 plus or minus square root of 8 over 4. And if we think of square root of 8 as square root of 4 times square root of 2, we're going to get a 1 once we separate, plus or minus 2 over 4, or 1/2 square root of 2, or just square root of 2 over 2. So now that's u. So u is equal to 1 plus or minus square root of 2 over 2. But we don't want what u is, we want what z is. So now we just need to take this one last step and say that 1 over z, since that's what u is 1 plus square root of 2 over 2. Right? So then if we multiply both sides by z, you get that 1 is equal to z plus square root of 2 over 2z. So then if we factor a z out, and divide by 1 plus square root of 2 over 2, right, we get that z is equal to 1 over 1 plus square root of 2 over 2. And I guess we should simplify this. So one thing we can do is we can multiply the top and the bottom by 2. And we'll get a 2 over 2 plus square root of 2. So we don't have any more compound fractions, but now we just need to multiply by the conjugate. So we don't have any roots in the denominator. So then we're going to get a 4 minus 2 square root of 2 over a 4 minus 2. So we get a 4 minus 2 square root of 2 over 2. So finally, we get that z is equal to 2 minus square root of 2. Right? I think I lost my plus or minus. Yeah. So this should be plus or minus each time. Right, so we get either a 2 minus square root of 2. Let's put it this way. Right, so this would give me actually, I'm going to get 2 minus square root of 2, or I'm going to get, if I were to take the subtraction one, I would get a 4 plus square root of 2, 2 square root of 2 over a 6, so I get a 2 over 3 plus 1/3 square root of 2. So those are my two answers. Okay, and then finally, let's do part B, which is 1 over x minus 1 squared plus 6 times 1 over x minus 1 minus 7. Right, now rather than multiplying this stuff out and then seeing what kind of substitution we make, why not just make u equal to 1 over x minus 1, so that u squared is 1 over x minus 1 squared. So then the equation becomes u squared plus 6u minus 7 is equal to 0, which we can factor as u minus 7, plus 7, u minus 1. So we get u is equal to negative 7 and u is equal to 1. So now if we substitute u in, we get that 1 over x minus 1 is equal to negative 7. So add 1. We get 1 over x is equal to negative 6. So then x is negative 1/6. Right? You could cross multiply. If you think of negative 6 as negative 6 over 1, cross multiply and you'll find that x is negative 1 over 6. And then finally for 1, we have 1 over x minus 1 is equal to 1. So add 1 to both sides. And we get that 1 over x is equal to 2. So x is 1/2. Okay, so that concludes this video on solving equations that lead to quadratics. Hope you enjoyed, and I'll see you next time.